Okay, this is our last unit on solving trig equations. What we're going to do is another type of substitution. You notice on the right hand side already, I did cross out that problem. We are never going to do that problem. But notice what I wrote underneath. Those three formulas, you've seen them before. It might have been a little while since you've seen them. They were in the beginning of the last unit. But it is something you need to know for this unit. So please write them down at this point, and we can see how we're going to substitute in to solve the problems that we have here today. So the first problem we have is 2 cos squared theta minus 3 sine theta equals 0. We have sines and cosines in there, and there's no GCF, so we've got to do something. And none of this is on the reference sheet like it was yesterday, so we have a little more work to do. What you do is you look at the piece that's squared. It's the cos squared. You go to your three identities. The one that has a cos squared in it is the first one. Now what your goal to do is now with that first formula is to make it a cos squared theta equals something. And the way you would do that would be to have to subtract that sine squared theta. I'm going to do it off to the side here just so you can see. If I want to make it a cos squared equal, like I said, you would have to subtract the sine squared. You know cos squared then is equivalent to 1 minus sine squared. What you're going to do is replace this cos squared with the 1 minus sine squared theta. So it's going to be 2 times 1 minus sine squared theta, and then rewrite the rest. Minus 3 sine theta equals 0. Distribute the 2. So it's going to be 2 minus 2 sine squared theta minus 3 sine theta equals 0. Write it in highest power to lowest power. So the squared goes first, then the sine theta, then the 2. Divide by a negative 2 so that way divide by a negative 1 so that way your sine squared theta is positive. All your signs change when you divide by negative 1. From here we can factor. Factors of 2 sine squared theta are just 2 sine theta and sine theta. Factors of 2 are 2 and 1. In order for it to add or subtract to a 3 in the middle, you've got to have a 2 on the second one and a 1 on the first one, if you set it up the way I do. It's going to be a plus 2 and a minus 1. The reason I know that is if I take 2 sine theta times 2, that's a 4 sine theta. If I take a negative 1 times sine theta, that's a negative sine theta. 4 minus 1 is a positive 3. From there we split it. Set it equal to 0. So in the first one I'll end up having to add the 1. So 2 sine theta equals 1. Divide by 2, sine theta equals 1/2. Take the inverse sine, you get 30. We've done this a few times now. You get 150 as your other angle. If you don't know that, you guys show me the work with the quadrants. On the right hand side, we're going to subtract a 2. So you'll have inverse sine of negative 2. When you type that in your calculator, you get an error, so it's undefined. So you're done there. Again, we're not going to do the second problem in that section. The third one we have here, we have to change the sine squared theta. Okay, again, you got sines and cosines, so you can't factor it yet. There's no GCF. We go back to our problems. We look for the one that has a sine squared in it, which is the first one again. Well, in order to make that a sine squared equals, you would have to subtract the cos squared theta. So sine squared theta would be equal to 1 minus cos squared theta. So this is going to be 2 times 1 minus cos squared theta plus 3 cos theta minus 3 equals 0. Distribute the 2. So 2 minus 2 cos squared theta plus 3 cos theta minus 3 equals 0. Write it in the correct order. We will combine that as like terms, so it's going to be a 2 minus 3 is that negative 1 at the end there. Make that a positive cosquared theta, so divide by negative 1, all your signs change. So 2 cosquared theta minus 3 cos theta plus 1 equals 0. Factor it. This will factor to 2 cos theta minus 1 and cos theta minus 1. Set them both equal to 0 and solve. So setting the first one equal to 0, I'm going to add the 1 to start. Divide by 2. So I get cos theta equals 1/2. I'm going to do my inverse cosine. So theta equals 60. And to get the second angle, we'll do a little graph. 60 is in quadrant 1. Cosine's positive there. Cosine is also positive in quadrant 4. My red reference angles are both 60 degrees. I want the blue angle, which is going to be 360 minus 60, which is 300. Same thing on the right hand side. I'm going to add the 1. I'm going to take the inverse cos of 1 and it gives me 0. Graphing that one. 0 degrees is on the positive x-axis. So I test the other side, which is 180. You type cos 180 in your calculator, it gives you a negative 1. It had to give you a positive 1, so it did not work, so 0 is the only answer there. This next one, notice there's no squareds in it or anything. So let's just change it around the way we already know how. You know secant is equal to 1 over cos theta. When you see a fraction like that, you're going to want to cross multiply. So you're going to get 2 cos squared theta equals 1. We can actually solve this using the square root method, so we can divide by 2. So we'll get cos squared theta equals 1/2. Take the square root. Remember, when we take the square root, we get 2 answers, one that's positive and one that's negative, so I'll split it. And you take your inverse, if I stay on the positive side first, you're going to take your inverse cos of radical 1/2. Typing it carefully, you get 45 degrees, which is in quadrant 1. In quadrant 1, cosine is positive. Cosine is also positive in quadrant 4. My red angles are reference angles. They are equal. The blue angle is the angle I want, which is 360 minus 45, which is 315. On the right-hand side, you're going to do inverse cos of negative radical 1/2, and you get 135 degrees. 135 degrees is in quadrant 2. Cosine is negative in quadrant 2. Cosine is also negative in quadrant 3. My red reference angles are equal. Those reference angles are not equal to 135. They are equal to 45. The reason I know that is because the other side that I have in black right here is 135, and a reference angle has to be 90 degrees or less. So I take 180 minus 135 to get the 45. The real angle I want is going to be this blue angle, which is 180 plus 45, which is 225. I'm going to have you guys try the third one, the next one, which is very similar to the one we just did. And I will start the fourth one. You guys will finish it. So I see a cotangent squared theta and a cosecant. So I go up to the top to my 3 options, and I look for the one that has a cotangent squared in it, which is my third one. I need that to read a cotangent squared equals. Sorry, my second one. So the way I make it read a cotangent squared equals is to subtract the 1. So cotangent squared will end up equaling cosecant squared theta minus 1. So going back down to the bottom, I'm going to change cotangent squared theta to cosecant squared theta minus 1 has to equal cosecant theta plus 1. Since it is a squared, I will set it equal to 0, move the right side to the left. So I'll have cosecant squared theta minus cosecant theta minus 2 equals 0. At this point, you will factor it, you will take reciprocals, and then you'll take the inverse of both sides and solve. So you can do the rest from here.